Send out, where is Star Trek? We're on Star Trek this morning. Dr. Bill Deese joins us from Louisiana Tech, our favorite chemistry professor. Nice to have you here today.
Well, it's nice to be here.
You hadn't been here for a while. You guys have been out of school.
That's right. We took a little break there for Christmas and New Year's.
But now you're back with
We're back going
more and better ways to blow us up.
That's right.
I just kid you. You've only actually tried to blow me up one time.
Well, anything for science.
That's right. Before we get started on today's project, real quickly, our trivia question today had to do with the Hindenburg. That was the answer. Why did the Hindenburg blow up?
Well, it was filled with hydrogen gas, and they don't really know what set it off, but I'm sure you remember what a hydrogen gas explosion is like.
Yes, I do. Yes, I do.
And,
very close to one.
And
in fact, it blew up around me.
Yeah, sometimes I reenact the Hindenburg incident in my classroom, and I get an oblong balloon and put a little gondola on it, and
I've seen the newsreel of that a lot of times, and it burns in a very odd way.
Well, it starts at the front for some reason and it burns fairly slowly from one end to the other.
Yes, it did.
And most people don't realize there were a great number of people that survived that.
They did.
That were on,
I think there were only 75 that were killed, and maybe 150 or so that got off.
I think they have reunions, so the survivors do. I'm not sure there are any left yet.
Well, good. I may be invited to that. All right, what are we going to do today?
Well, we're going to do a little chemistry today. We're going to, can you tell me what chemistry is? It's kind of hard to define sometimes.
I can't tell you.
It's the study of matter and the changes that matter undergoes.
The study of matter and the changes that matter undergo. I'll be ready for the first
so, when I ask fourth graders and third graders what chemistry is, a lot of them will say it's the study of chemicals, and that's a perfectly good definition. And we have a couple of chemicals here today.
That's not gunpowder, is it?
No, no. In fact, notice this isn't labeled. Normally, I don't even give out the chemical name. It's not that important for what we want to show, but that's potassium permanganate. Can you tell me some physical properties of that?
It's black.
It's okay. Is it a solid, liquid, or a gas?
It's a solid.
Okay. And so another physical property we could determine, or at least look up for that, would be its melting point, the temperature at which it melts.
And becomes a
liquid.
Okay.
And then we could take the liquid and measure its boiling point. But those are physical properties we're talking about. And here's another chemical. What do you think that is?
Liquid. It's thicker than water.
Right, it's not water. It has a higher viscosity
than
water.
It's
glycerin, actually.
Okay.
And we could measure its boiling point, which would be a physical property.
Glycerin sounds like half of nitroglycerin.
There's a similarity sometimes. Don't drop that. No, this is perfectly safe, and it's perfectly stable all by itself.
Okay, let's do something with it quick, because I want us to have time to talk.
Okay, well, I have some of our permanganate in this. This is called a mortar.
Mortar and pestle.
And a pestle.
Okay.
Okay, and it's used to grind up materials so that you get a very small particle size.
Okay.
Okay, and if you have a small particle size, that means you can mix your reagents together really well.
Okay, I think you've done a good job. This is almost, it's almost like sand. Yeah, very fine.
I forgot my spatula, so I borrowed a spoon from the
This is a station. This is a regular TV station spoon.
I'm going to put a pile of our black solid here on the pad. Okay.
You guys see that? It's awfully hard to see, but there it is.
Hard to see. And I'm going to make an indention in that with the end of our pestle.
Okay.
All right. And then we're going to put a few drops of glycerin into our little indention here.
Okay.
And we're going to mix two chemicals together. Now, what's the most common thing you get when you mix two chemicals together?
A
mixture. You get a mixture.
When you've been here,
Just what I was going to say.
It's been smoke and fire.
Okay. Most of the time when you mix two chemicals together, you only get a mixture. You don't get a chemical change or a chemical reaction. And let's do an experiment. Let's see what happens when we mix these together. Okay?
You're scaring me.
Nothing's happened so far. It's just kind of beating up.
So it looks like all we're going to get... what's something? What? Smoke? Okay. Ooh. Now, do you think a chemical reaction occurred?
Yes.
Obviously.
What about you, Jim?
Definitely.
Definitely.
So.
What makes you think that? I mean, what observations?
Smoke and the fire and the reaction.
Smoke, flame, and whatever.
Heat.
Okay. Did you happen to notice what color that flame was?
It was kind of orange, yellow.
Orange, yellow? Purple. I thought it was more lavender or purple.
Okay, well, I was
His
getting
vision.
Of course, I'm being colorblind.
Colorblind.
No, I'm not. No, I'm not.
Okay, now from our observations, we've decided that a chemical reaction may have occurred. And to test our hypothesis,
Okay.
we need to do another test,
All right.
okay, design an experiment. And I have brought here some tubes that we can do tests in. So what should we call these, Dave?
Test tube.
Test tubes. That's a great idea.
Very good. Test us at the
Okay,
end.
so now this is another chemical. This is just a solution of sodium hydroxide. And I'm going to pour an equal amount into each test tube, okay,
Okay.
approximately. And then I want to take a little bit of our unreacted permanganate, just
Put it in
a
one.
few crystals,
Okay.
and put that in one side,
All right.
and shake that up, and
And
you
we're
can
gonna-
see
It's purple.
you get a very intense purple color, okay?
And we're going to take some of the
Now
other.
we'll take some of our
Now,
reacted,
why are you picking it up with that stuff?
well, it might still be hot,
Okay.
okay?
Oh, it's
And
solid.
try to break that
The
apart.
consistency of it
Yeah,
certainly
and
changed.
it's more of a black, we've changed a black solid into a black solid,
Yeah.
Yeah,
okay?
okay.
But let's put some of that into the same chemical and mix that up, and you can see
Much
Blue
different
green.
color.
a quite, you know, a totally different color. That's a green
So that
material.
means we've had a chemical reaction.
Right, that at least verifies or helps support our hypothesis that a chemical change occurred.
Okay.
And so, and this was a spontaneous chemical reaction where all we had to do was mix the reagents, and we eventually got a chemical reaction. And so, you know, it's things like this that we do for
A little bit of the technique that chemists use to determine things. That's
Right.
what we're really talking about then.
And-
That was interesting, and it was basically harmless as far
That's
as...
right. I was afraid we
being
might set
deadly.
off the smoke alarms, but
Nope,
we got away
we
with
didn't.
it that way. So,
Okay.
This is potassium permanganate, the purple, and the green material is actually potassium manganate. And so a slight chemical change has occurred, and we changed the environment around the manganese atoms, and it completely changed the color of it.
You know,
Interesting.
now I understand that every time you hear, I understand more why one of my sons is in chemical engineering and why he loves the chemistry part.
Is
It's
that right?
nice. It's nice
Well,
to have you here
Interesting.
today.
Well,
You're
thanks a
always
lot.
an interesting guy to have on the show.
Well, it's a lot of fun coming over.
We're going to take a break. We'll come back without the goggles, but with the hat sometime a little later on.
Dave
We'll
will
be
wear
right
it.
back. No, no hat for me. Okay, hang around and we'll do